In this video, we're going to convert from rectangular coordinates to polar coordinates. It says find the polar coordinates of a point with Cartesian coordinates x, y equal root 3 and 1. So we want to go now from x, y to radius theta. Now to do this, we're going to have to use some trigonometry. The first thing I'm going to do is I'm going to draw a triangle. It says x, y, so x is root 3, y is 1. So I've got a triangle that looks like this. Now I want to find this angle, because I need that angle theta for my coordinate, and I also want to find the radius. The radius should be pretty easy because I'm going to use the Pythagorean theorem to find it. And when I do that, I get r is equal to root of, if I square this cube root, or not cube root, root of 3, that'd be 3 plus 1. So I get r is equal to root 4, which is 2. So I know that the first part of my coordinate is 2. So I can rule out these two options and that option. Then I'm going to go ahead and find theta. What we have to do to find theta is we need to use tangent here. Yeah, we could use tangent. We could also use root 3. Now that we know r is 2, we could use cosine if we wanted to. Let's use cosine here. Cosine theta is equal to root 3 over 2. When does this occur? Well, this occurs when theta is equal to, so root 3 over 2, that would be at, root 3 over 2. Let's pull out our unit circle piece. Well, root 3 over 2, if we draw the unit circle here, that's cosine is going to be, let's see, that's 0. There's pi over 6, pi over 4, and pi over 3. This would occur actually at pi over 6 right here, because cosine would be longer, x would be longer here than y is. So we end up with theta being pi over 6 here. So we get 2 comma pi over 6 for our rectangular coordinate. And technically we're using the inverse here. We would say that theta is equal to cosine inverse of root 3 over 2. But I like to think of it like, when is cosine root 3 over 2 at what angle, and go back to our unit circle talks.